So I'm here today to talk about data mesh, which is an enterprise architectural pattern put forth by ThoughtWorks, and some of my thoughts on how it works with MongoDB and kind of sharing data within the enterprise. And it's not letting me advance my slide. There we go. So myself, Jai Hirsch, I am enterprise data architect at CARFAX. I've played quite a few roles at CARFAX over the almost 15 years now that I've been there. I spent a lot of that time working with MongoDB, running it in production since version 1.8, and working mostly on the core vehicle history database, which I think just last month passed 25 billion documents inside of MongoDB, which is also a geo-distributed database running in 3 different data centers across the US. So it's a challenge moving that much data around and everybody who wants to access it. My current focus is very much on distributed data systems, how all that data gets moved in between departments, how it feeds into reporting strategies. I work way too much with marketing these days, but such is the life of an enterprise architect. If you ever want to chat with me or engage, always feel free. You can reach out to me on Twitter, or you can find me on LinkedIn. I'm generally always happy to discuss MongoDB, other databases, Hadoop, big data, and all the other fun stuff around the data architecture. So just a little bit of information about data mesh to back it up. This is definitely not anything I came up with on my own, although it definitely pulls in a lot of concepts and beliefs that I've had for a long time. And it was originally published by Zhamak Begani, Director of Emerging Technologies at ThoughtWorks North America. And I highly recommend reading her articles on this if it's a topic that you find interest in and want to find out more. The original one was how to move beyond monolithic data lake to a distributed data mesh. And the follow-up article to that is Data Mesh Principles and Logical Architecture. It takes a little while to get all the way through the reading. It's a little dense, but it's just fascinating. I think I've read both of those articles probably well over 20 or 30 times, and I think I find something new in it every time I read through it. Also, a couple other talks that I recommend. JP Morgan has some really good talks that they've done on how they implemented the data lake, and they kind of dive in to data security and and compliance within large corporations, and how you have to move and be very careful with when you move the data around. There's also some excellent talks from Zalando, I think I'm pronouncing that right, which is a clothing seller in Europe. And so some of their talks, I've actually, some of my content, I borrowed from some of their talks because they did it so well. So I highly recommend following those up. And if you want to reach out, I can provide any of the links or anything that I have inside of this talk. So what is the data mesh really all about, and why am I up here talking about it? And a lot of it has to do with reducing time to market for data intensive products. Data is kind of everything these days, and if it's not treated right, you can really get bogged down in trying to figure out what you're supposed to use, what's the right data, finding where the data exists, and reducing the duplication of efforts. A lot of times when there's a term out there called dark data, which is data where you don't really know what to do with it, and you may have multiple people or departments or teams coming together, and each one having to do the exact same thing as they figure out what that data is and how to use it, instead of having a light shown directly on it so that people can quickly pick up that data and run with it. One of the big problems I've seen in my professional career is applications and reporting not using the same data. And so the customer sees one thing when they're in the environment and running something, but then they get hit by the marketing campaigns or sales strategy teams, and they're seeing a different set of data. And when as a company, when you speak with different voices, it very much confuses your customers. And something that we really want to avoid at all cost, and really speak with one voice when the data is concerned, and let the data tell the story. And finally, it's really all about embracing the reality of the ever-present, ubiquitous, distributed nature, and I forgot to add in the ever-growing nature of data. Data is not slowing down. It's just going to get bigger, faster, and more important in every aspect of what we do. So at its core, a lot of this is really about bridging what they call the Great Divide between the operational systems architecture and the big data and analytical architecture. So of course we have to run the business, in the operational sense. The applications have to run, the websites have to be up, customers have to be able to engage. But it gets deeper to that within the analytical side, that we want to optimize the business. How are we making sure that everything's running correctly, as smoothly? Where can we cut the costs? And we come back and say, now with our capabilities and services, how do we know, what they're really doing? How do we see, what's happening within those services? Are they being used right? What can we gain out of that? What do we know from our customers, from the way that they engage? And protecting the operational data within the application itself, but we still need to have analytical data. So how do we get at that operational data in order to analyze it and gain additional value from it? And from our products and applications, how do we report on those? How do we build machine learning models that will help us build the right products and applications? How to report on what those applications are doing? In the communication within the operational systems, one department may need another department's data. How do we communicate that across? And what are the data transfer? What are the copying policies within the company to ensure that everything's moving in a timely and safe manner through the company? And while the operational systems and architecture are very, they have to worry about their infrastructure. Are we a data center company and have to stand up enough servers in time? Are we up in the, in one of the clouds and, running on Kubernetes? Well, how do we make sure that we're still worrying about cost? And, infinite scale at infinite cost is one of the worries, within that application side. But we also have to think on the analytics of those data pipelines and the storage infrastructure. How do we move that data between systems? How do we store that data? How do we archive that data? And, really, it's often in the past, these two sides of the building don't really talk to each other incredibly well. And the data mesh is an approach to really bring the two sides together and to work in unison. So one of the big questions is, who owns the data? And the mesh uses this term called a data byproduct, which occurs when the team that produces the data does not feel ownership for how it's being used. So for example, I have a product and, application, and I have a database behind it, and it is designed completely for my customer, that website sitting on top of it and people who are interacting with it. And if somebody else comes in and uses that for what it's not designed for, or possibly even without my knowledge, then that would be a byproduct. And we'll dive a little bit deeper into that scenario in a moment, as well as that centralized engineering team or data engineering team, often which falls within a, kind of a, either purely called a data engineering team, or your business intelligence group, or maybe just your manager who likes to get in the middle of things and look at data. Those people don't own the data that's being produced, and don't necessarily own the business rules, which are on the other side. And so they are, hooking into possibly that operational database, implementing rules from, somebody in marketing. And so they, but then get stuck, with complaints when the data is wrong or the rules are wrong, even though that they have no true ownership of it, and data quality can suffer. So let's consider the following workflow. This diagram, while based on a issue that I had to deal with, the names and faces have been changed to protect the innocent. And so we had this application, up and running, and the team had picked MongoDB for its backing database. It worked lovely, and customers were happy. The application was running well. The data was nice, document model, well modeled. Everybody was happy until one day when somebody from the marketing department decided, what we really need is some customer engagement emails that are based on how our customers are interacting with the application. So they went to their BI team and said, we really want these, and and here's how I want it validated, and these are the users on which markets which I want to target in this way. BI said, okay. So they took those business rules and they needed to go find the data to back it with. And in years past, somebody from the BI department, talked to one of the application engineers, and the application engineer, handed out a login to the Mongo database and said, here's our basic structure. And so the BI department hooked in a, kind of big metal ETL system straight onto that Mongo database and started extracting data. And everything worked really great until one day when it didn't. And this, really happened due to a schema change within the Mongo database that was done to serve up the application. And, the application was happy, the customer was happy, and they had used a versioning system within their Mongo document so that it could talk to the new application. However, the person from the BI department who had set up that initial pipeline no longer worked at the company, nor did that application engineer who had handed out the access to the database and had walked them through the schema. So nobody in the current BI department had any idea that a change was coming within the data structure. However, it didn't actually break the pipeline. All it did was cause some information to no longer be present, which subsequently messed up the business rules and caused invalid emails to be sent out to the customer. Well, customers were very confused about these emails coming out to them, who they had found some value in before, but now seemed to be wildly inaccurate. They started complaining to the tier 1 support team. Tier 1 support team didn't know what was going on. They went to marketing. Marketing didn't know what was going on. They went to BI. BI didn't know what was going on. So they went to the application, and several weeks went by, and with prioritization and JIRA cards and everything else before it was figured out. And the BI team moved finally the ETL pipeline to the new version of the document. But there's nothing protecting them from this happening again, because the application team sees this as a data byproduct. They're not in the business of serving up customer engagement email marketing. They are in the business of supporting their application and their customers who use it. And the story also highlights that lack of ownership by the pipeline team. They got stuck in the middle of diagnosing the data problem and the issue with the rules engine or with the business rules, even though they didn't have ownership of either side, and they got stuck in the middle of it and led to something unhappy. Now, this can also start to grow at scale, because there's not just one application out there that's having data interacting with the system, and there's not just one person in marketing who wants these reports. You have management, you have customer engagement, marketing, all these teams who want this data. And you have all these teams producing the data, and it's very hard to scale that centralized data engineering team to meet those needs. So they're constantly being stuck as a bottleneck and fighting fires and reacting to change and not getting their actual, and then they have day jobs as well as they're trying to produce value for the company. And this can lead to a really disappointing reoccurring pattern. And if you've ever been on a data engineering team, you may have seen this, is where we have our source domain product teams happily generating data, more data every day, more products every day, as we drive to engage the customer and serve up content. We have other teams, decision makers, data scientists, who want to consume that data. They need it. They need that data that the domain teams are producing in order to get value to the company from their side. And we have these data engineers stuck in the center, making sure everything's wired together. And some of the data engineering teams, within this and BI teams, they're a 24/7 team because the data has to flow. And that means that, within the DevOps world, we have this idea that if an application comes down, developers responsible, and they respond and make sure that the product is up and running and serving customers. Well, it's a little harder when you think about that data going inside, because just because that pipeline breaks doesn't necessarily mean that the front end product broke. And so their SLA for fixing the data feed may be different. However, those data engineers are stuck because if things start backing up, it can take days or even weeks to recover from a data outage or that data downtime. And it leads to some very unhappy data engineers. So kind of why is this? When we centralize this data platform and when everything's running, it kind of looks great because, over here on the left, we have, all these products that are coming through. And on the right, we have consumers of those data products. And that centralized platform, well, it looks fine when nothing's broken. However, when there is that break, we come back to that, who's responsible for it? Who knows? And a centralized team, are they chasing down developers and application databases and operational databases to fix the reporting that are coming out the other side, or making sure that that data throughput is going from one department or application to another department or application. And there's kind of this idea of the data monolith, and much as within software architecture, microservices, and the service-oriented approach has become very popular because of how it scales and its durability. The mesh applies these same concepts in order to your data platforms, that breaking down this monolith into small services and putting the ownership of the data where it belongs. All right, so anybody have any questions on the problem statement up to this point? All right, so let's move forward to the data mesh and really what it's all about. And it is about applying product thinking to your data, using domain-driven distributed architecture techniques applied to your data. And then data infrastructure as a platform in order to allow the other 2 points to work, ultimately bringing all of this together to create more value from your data faster. So product thinking applied to data. Often, our project managers are really good at selling a project or product. And often that's because, their bonuses and salaries rely on their product or project going live. And so if we think about our data as the same way as that product, what is the market for the data of my application? Who would have interest in it? What, aside from just that front end, what's serving up the website, what are other interesting aspects to it that people within the company might need? what are the desires of those customers? Does marketing need my data, and why do they need the data? Does my operations team need special information out of it? Does there's something that goes straight up to the CEO so he can make strategic decisions? And then how do I market it? How do I let them know that this data exists? Are they happy? Are they getting that data on time? Can they trust it? What is the unique selling position of this data? Why is this data better than anyone? Why is this data better than other places that it may be accessible within the company? Why should it be picked up from here? Excuse me. And then what price is justified? I currently worked on a small project, which was, mostly an internal application. However, the department and team that was producing it, they generally have a, 5 nines requirement, always has to be up, always has to be in multi-region, multi-zone, high-end products. And so they took on this small project and immediately like, oh, well, we have to replicate this data between US East 1 and East 2. And we're thinking about holding a backup copy, over in this other region within AWS. And, and we were working out the replication costs and storage costs. And, and then finally we stood back and said, wait, this is just an internal product. If it's not up for 15 or 20 minutes, it really doesn't matter. And it's always recoverable and doesn't have an impact on the front end. Therefore, the price of moving this data everywhere and storing it everywhere is simply not worth the value that it's giving to the company. So I think it's really important to think about your data in that way. And is the price justified for how I want to store it and use it? So that data product is the fundamental building block for the mesh. Oh, I forgot to mention one thing inside of the slide. So it centers around this data product manager. And as a role of somebody who says, this is the data within my domain, within my system. And really to opt in to any of that data, there has to be a documented handshake between, or fist bump in the post-COVID or in the COVID days, so we don't shake hands. That it has to be documented and an opt-in strategy that another product, it needs data from this given product. And using, thinking about that role just as the product manager or product manager, equally important. It certainly be shared responsibility at, at smaller companies that probably don't want, three product managers running your team. You'll never get anything done and always be in meetings. But I think a very important and interesting aspect to think about. So the data product is the fundamental building block for the data mesh. And this really, if you're familiar at all with domain-driven design within software architecture, really about, pulling the logical structures together operationally within your domain to make sure that that changed within one area of your code base or a domain doesn't affect a domain that isn't, that is distinct. So thinking about this, data in the same way, and this is data which is exposed outside of the domain. So within your domain, that operational data should really be held as privately as possible. And kind of like in object-oriented programming, this idea of encapsulation, you really shouldn't make that private data public. And at least as little as possible, and only exposed through kind of those approved methods to make sure that the correct data is being picked up. As I always like to say, don't make your privates public. So the data domain should be discoverable. That is, there needs to be a standard across the organization on how data is found. And this may be a documentation of the from domains, there is a strategic way to pull data via API. Like we may have a GraphQL backing system on how I discover and get into that data. We may have S3, Parquet files published to an S3 bucket. And this is a known path for coming in and picking up data from this system. There may be a known stream of data coming off of the system, that'd be that Kinesis or Kafka or Pulsar or streaming technology, but very much, organizationally accepted that these are the ways in which you move data out of a domain within the mesh. And addressability, following up on that. So, once again, that there is, the way that we do, how we can find it. So self-describing is that, you have a published schema for your data, and people can trust that your schema is going to work, as well as, the data definitions, within your data to help other domains understand what's there. Common security models, incredibly important, and understanding the security risks of the data that are being exposed from the domain. If you have a customer domain, which is has the PII data within it, their name, their address, their email, phone number, etc. You obviously don't want to have that information in a publicly discoverable area within a domain. So you need to make sure that is secured. And while it may be available within the mesh for other domains that absolutely have to have that security layer has to be in place and consistent across everything to make sure that that the rules are being followed around sensitive data. So trustworthiness of the data, this is kind of the SLAs and SLOs of data moving across the system. Once I have opted in and, that fist bump has been made, can I trust that the data will not change? That it will show up in a timely fashion, as expected? Can I trust that the format inside isn't going to change? I'm not, a nullable field or, suddenly a always filled field isn't going to suddenly be null throughout the data. So really understanding and being able to trust that data can move across the mesh in a trustworthy way. And interoperability, which I feel is probably the single most important piece of all of it, is really how does your data work within other domains? A lot of this, at this, kind of the naive, simplistic side, very much has to do with, it'd be kind of nice if we all used the same date format within our data, or, it'd be awfully nice if the naming conventions were the same for this customer ID across, all of our systems and domains. But when you dive down deep into it, it really is, if my data is not interoperable, it is not worth putting into the mesh, because the other domains can't pick it up and integrate it directly into their systems. And that's partially why, the cataloging and metadata becomes so important when this data gets exposed outside of your domain. All right, and next we have the data infrastructure as a platform. And this is where we, have the storage, the pipelines, the catalogs, the access control in place to allow the data to move onto the mesh and between the different domains. And it's important to note that this is not a data platform, in the case that BI is not allowed to run reports directly out of this platform. If you start putting domain knowledge and your business rules into the data infrastructure, you're well on your way straight back to that data monolith, where what is supposed to be a environment for understanding, your data and moving it in between your systems, it can quickly just become, what's dreaded about the data lakes is it becomes the data swamp, and just suddenly everything's in there. Somebody snuck a production application onto there because it was simple. You can really, I think, easily go down a dark path, and getting really swampy really quickly. And I do mention a few pieces of technology within this, such as, the Kafka, S3, Spark, Apache Beam. MongoDB has some stuff that are interesting here. I think that MongoDB's data lake is interesting, which allows you to query files in the S3 system or other cloud storage systems directly from within Mongo. So, there's a lot of different ways, and it's important to know that this is not about the technology or individual pieces of it. It is much more about how you're looking to apply it. And in the end, what we really want here is a platform we can all share. It's crisp, easy, refreshing. But I like to throw a joke into all my presentations, and I found this platform beer while I was searching the internet, and I've never been to Cleveland, I'll admit, but I kind of want to go now just to buy some beer from the platform brewery that I can use in my talks about platforms. But this is really about, this isn't BI's mesh. This isn't operations mesh. This isn't, individual products or domains. This is about, as a company, how we move data in between everything. And I will say that as an enterprise architecture, it is geared more towards very large corporations with lots of data and lots of departments, and really breaking down those silos and getting the data into the hands of everybody who needs it. And, the democratization of data is one of the buzzwords that gets thrown around. But I think a lot of these concepts do also very much apply at the small level as well. And, because we hope, if you're in a small company or startup, the end goal is to be a large company. And so I think thinking about these concepts, even on the small level, are incredibly important and can help build towards a brighter future. So as I was getting to in that previous slide, it really is a mindset shift and not a technology solution. Within that data monolith, we have the centralization of ownership, or in some cases of problems I've worked with, of no ownership within a data product, to the decentralized ownership, and that is that those domains own their data. Moving away from those pipelines as the first class concern, because that engineering team, once again, doesn't have ownership of the data being produced or the data being consumed. It is about that domain, and the domain data being the first class concern and the source of truth for the data. Eliminating those data as a byproduct, which I mentioned earlier, no longer just sneaking into an operational database and running extracts, and moving that towards data as a product, so that that opt-in strategy, so you can trust what's being consumed. Moving away from that siloed data engineering team to a cross-functional domain data teams. Because data engineering and data operations is an expensive skill set. I've been writing up a job description lately and throwing the skill sets down, and going out to Glassdoor and various other things, and just like, geez, I need to go get a job as a data platform engineer. They get paid incredibly well. So it's a highly valued skill set. So when you get that skill set, is necessary, don't isolate them. Have them work with the producer and consumer teams, so the ownership can be shared across, and don't make them unhappy by being a 24/7, getting paged at 3 o'clock in the morning because a pipeline failed. Centralizing, moving away from centralized data lakes and data warehouses to ecosystems as data products. And this in no way means that data lakes or warehouses go away. It means that they become very much specialized within the domain. And so that may be that there's a data lake within each domain. But a lot of that is to avoid, that data swamp context or the legacy data warehouse that had everything in the company inside of it and required $10 million worth of hardware to make it run. Really scaling it out horizontally instead of vertically in getting to our ecosystem of data products. So kind of that recap. So what we want to do is move away from a bottleneck to the infrastructure platform, moving away from that data monolith to interoperable services. And centralizing those services with global interoperability. Excuse me. So once again, I have a lot of technology on this slide, and I do it mostly just, to show a possibility. I'll admit that these are technologies which I like personally, and to some extent do recommend, but, it is, it is the theory and mindset, not the technology that really drives this. And so we have, kind of on our inside, we have, those API calls, the S3 buckets, Kafka, which I talked to, and those addressable and discoverable processes of moving data onto the mesh. In the center, we have the metadata layer and catalog, which allows us to understand that data and find what's necessary. In the center of it, we have a fast query engine such as Dremio. Mongo Data Lake may work here as well for your uses, and then a engine such as Spark under the hood to help move the data around and along. We'll talk about the fast query engine for a second in Dremio, just because I find it an incredibly powerful data product that allows for some data virtualization. So one of the cases that I used it for recently, it is actually querying, it queries into Mongo, it queries into an Oracle table, and queries an Excel spreadsheet, which I dumped onto the system. And it joins those three systems together and creates a data virtualization based on Parquet files behind it. And it refreshes nightly, which allows me to come in and do some very fast analysis of that data during the day, because they're also using a layer on top of Parquet called Arrow, which allows that those big data files to be held completely within memory, running about 10 times faster than the results I was getting previously from raw Parquet files within the system. And so on the Spark side, Spark's a great engine, but this could also be Elastic MapReduce. It could be, traditional Hadoop. It could be, your equivalent over on GCP or Azure. This is up to you. How you want to move it through. It's the concept which is important. Then at the bottom there, I have Apache Beam, which is a data pipeline builder, one I really like, but it's exceptionally Java heavy. And if you don't really know your Streams API and have good Java development, I would not recommend introducing Apache Beam into your ecosystem. This is where something like, Amazon Glue or, ETL of your choice or pipeline builder, your Airflow, into that nature. Now over in Google, they actually have I believe it's called the Google Cloud Data Flow, which is actually a managed Apache Beam, and it makes me wish I could kind of move a lot of my pipelines over onto GCP because it's spectacular. However, most of my stuff runs on AWS and don't really want to send the volume of data across cloud providers to be necessary. But that being said, pick the pipeline builder that you really like. There's a lot of really good ones out there. And at the end, we all sing Kumbaya and have a decentralized storage and ownership while we've centralized our infrastructure and governance layers, where we have that data product manager interacting between the domains, trusting and opting into the data that's moving across your system. In all of this, running the data infrastructure as the platform under the hood, which allows for that developer experience to quickly move data around. My dream goal is that, once that data is there, cataloged and accepted, in a few lines of YAML, I can have a pipeline up and running and moving that data between one domain and another in a known context and being able to trust that everything is working as expected. All right, so let's go back and revisit our semi-fictional workflow. So the data engineering team I work with went back and we were looking at the queries which the BI team at the time had been running to extract that data out of the Mongo database. And we had found that some of the data had shifted, and really to do right would have required indexing within the Mongo database that wasn't useful for the application itself and really only good for the extractions, and had actually been causing some mysterious slowdowns that the DBAs had been beating their heads against, trying to figure out why these slowdowns occurred within Mongo. In fact, these batch extracts, one of which wasn't using an index correctly. But those added indexes really would have ballooned memory, for that index storage, and really wasn't a great option. We could have run, some aggregations and put that out into other, Mongo tables, but that didn't feel right either, because we didn't want to cause that stress on an operational database, which had to be extremely high performant. And so the MongoDB Kafka connector had just been released, and actually talked with Hans at one of the MongoDB Worlds, and we got really excited about it. And so we came back and we implemented a change stream on top of the Mongo database, which allowed us to, kind of real-time stream those changes to the database and the information onto Kafka. And we piped that Kafka stream up to S3 buckets in kind of time window Parquet files, which we were then able to set up a Spark pipeline, which would hit those Parquet files in a timed fashion and get that information out to the marketing. We worked with them to implement their checks and business rules on the data coming out, and they were able to get the right emails, marketing campaigns out to the customers. And so we see now that we've really split the domains across there, where the application developers are now responsible for their change stream, and they have accepted responsibility into it, that they have to, that it is part of their application, that the data coming out of it, which is feeding eventually into marketing, is just as important as that operational data, which is serving up to the application. The platform engineering team is responsible for making sure that Kafka is available and up and running, and that the S3 buckets have the agreed upon security and constraints within it, and providing that the Spark engine is there and available. But they are not responsible for the data which is coming through from the application team, and they are not responsible for the business rules that the marketing team needs to apply. And it took a fair amount of work to get there, and I'll openly admit that it's not quite as pretty as I represent within this image, but it's quite functional, and has definitely drove value, and is kind of one of the baby steps towards moving towards the data mesh concepts. Because while you certainly can pay ThoughtWorks probably tens of millions of dollars, and they will come in and build a data mesh for you, most of our budgets aren't quite that exciting, and so we have to take these baby steps towards moving in this direction. And finally, I'll end on something which I think is incredibly important in a trend called data observability, which is really kind of pushing the idea of the observability model within software engineering towards data. And I first learned this term at a presentation from a company called Monte Carlo. And I would highly recommend going out and reading their CEO Bar Moses blogs, because she has some really incredible insights into not only the data mesh and how data flows, and what data downtime really means for companies. That if the data outages can be just as important or even more important than application outages to your front end, and really has what she liked to refer to as the 5 pillars of data observation. That being freshness, which kind of seeks to understand how up to date your data is. On that mesh, if you're responsible for it, you really want to know that it's working, and you're serving up the data as expected in a timely fashion, because stale data can actually, in some points, be worse than missing data, because you may get the wrong results out the other side without some quality checks there. The distribution of data, which is really a function of your data's possible values. Kind of think of this as the histograms of your data, and what are the acceptable ranges, and it can give you insights into whether or not your tables can be trusted with expected data. So one of these, again, if suddenly you drop down to all nulls in a table or in a column, you are suddenly well outside of your expected distribution, and should probably raise alarms on your data. So the volume of your data, understanding that, if on a daily you normally get 5 million rows into an export, and suddenly you drop down to 200 rows, there's probably something wrong in the system. And being able to stun, especially over time, of your data volumes, very important to make sure you can trust what's going in. Making sure that you're getting your schema design, and monitoring if there's any change within your schema, as this can show that the data is fundamentally broken and not able to be used within the ecosystem, and this very much has to do with the trustability. And finally, knowing the lineage of your data, and that is, so when data breaks, the first question is always, well, where did it break? And in most complicated systems, it's not necessarily just one database in the line. You have your pipelines, you have big data possibly involved, you have reporting tables. And so where within that system did it break? Which can also help very much if you know the freshness of every stage within your application. And I would recommend, if data is your thing, of taking a look at Monte Carlo. I believe they're still in startup phase right now, but it's a really fascinating application that they wrote, which ties in to, I think they're generally in the cloud, but just a personal sales pitch for me that they're worth taking a look at. And that's the end of my slideshow.